if I drag this in, or if I right click and type in my function, you can go ahead and call it. So basically this is going to execute my function. So let's go ahead and actually do something with it. Now inside my function, this is blank right now. I can just go ahead and print a string, and we can call this one my function is executed. So I think I butchered the spelling, but doesn't matter. So if I go ahead and press play, you see my function is executed. Now we can also pass in values. So I have created this points variable here. So just create a new variable and make it of type integer and call it points. Now if you head into your function and click on this block right here, you can actually add input and output parameters. So if I click on the plus icon and change the type to integer, and I can call this one points. So I can take this points value from outside the function. So if you look at this now, you see I can pass in points. So that's pretty handy. Now I can go ahead and print this out as well. So I can print out my function is executed, and I can print out points as well. And if you double click on the wire, you can use the reroute node to keep things a bit clean. Now if I press play, you see you get my function is executed and you get 0. Now if I change the value of points, for example, you see we get that number. So this is basically how input parameters work. Now what if you had some return value? Now let's say instead of points this was health. So let me just call this one health. So compile that. And over here if I click on this once again, I can add in an output. And you see it creates a return node for us. So this is basically like your return keyword in C++. So when your function goes to this, it's going to exit the function, and the value whatever you want is going to be returned. Now you need not have it. You can have an empty return node as well. Now in our case, let's just return a boolean, and let's just call it be killed, for example. And let's change the name of this to be health as well. And we could do a simple if check. We will talk about if as soon as we finish functions, events and stuff like that. So if I can't do that, so let me just grab in an if. If this value, that is our health, is less than 0 or less than or equal to 0, then what we can do is, if it is true, and if you type in Ctrl D, you can have two return nodes. So if our health is less than 0, it's going to be true, otherwise it's going to be a false. Now you can go ahead and print this out over here. Now our health is 32, so we should have false. Let's say we set our health to be -1, which is invalid of course, but we get true. So this is how you can return values outside a function. Now one aspect of functions which I did not cover, and I'm recording this a bit later, it is going to be local variables. So what if you had some variable which you wanted only within a function? So let's say for example we have a variable temp, for example. So let's say you wanted a number to be stored temporarily inside. So for that case you would use this local variable option. They work exactly the same as as it works in C++. And one more thing, the input parameters whatever you take are also local variables. So you can just grab an in, and instead of dragging this, actually you can right click and type in, and if I just get it, so I should find it at the very end or somewhere, or rather let me just type it, get in. So in is a really commonly used word, so that's the reason we are getting it so many times here. So let's actually change it. So let's just type in 1 2 3, let's say. So in 1 2 3, so you can get it actually. So you don't actually have to drag this. Let's say you have a large blueprint graph, you don't have to drag it actually. You could just do this over here. That works totally fine as well. Even over here actually, you could do this and it's totally valid. So that's about it for local variables. As you use them, you will kind of understand their purpose, but without a solid example, we will not actually be able to tell the use case. However, once we actually get to the end where we actually create something, that is when we'll get to practical examples. At the base level, those are what functions are, and we will go a lot more in depth about functions, events and stuff, so not to worry about that. I've just gone ahead and deleted that. Let's create a new one once again. And now let's talk about the limitations, and let's talk about the next type of scripting feature in Blueprint. Now, one limitation that you'd see is you cannot add a delay. So if I right click and type in delay, you actually don't get a delay node. The reason is you cannot have latent nodes inside a function in Blueprint. So delay is actually a latent function. So what I mean by that is it actually takes some time to execute. So let's say I cut or copy this and paste it in here. You see, I cannot do that. It says one or more copied nodes could not be pasted into this graph. So the way you can handle this is you can use a macro. Now macros in Blueprints are more like functions than C++ macros. So they work a little bit different. Now if I call this one my macro, for example, I can go ahead and add a delay. So I can hold down D on my keyboard and left click and I can add in a delay. One thing you'll notice is by default it doesn't have any input or output pins. You can go ahead and add that. But there is another advantage of macros. Now for example, let's say we have a database on our server, and let's say it takes some time to retrieve the data. So let's say it takes around 0.5 seconds for your computer to connect to the database and retrieve the data. This is just an example. It could be anything that takes time. For example, the prime number program takes some time to execute after you go to a larger number. So while this is being executed, now let's say you just wanted to print out something saying that it's starting, and then you want to do something else when it's completed. This is where it can come handy. Now you can type in print string and you can call this one starting now. You could come in here and now you'd notice this execution pin got disconnected. You can't do them parallelly, but there's a workaround for that. You can type in sequence, and over here you can just print this out and then you can go ahead and perform this. And over here in the output as well, you can drag this in, and a handy thing which you cannot do in your return node in your function is you can have one more of these. So now if I just give a longer delay so that we can recognize it, and if I drag in my macro and if I print out strings over here and over here, so we'll call this one done, and here let's just print starting underscore outside, for example. So if I press play, starting now and starting outside got executed first, then after 2 seconds our done was executed. So things like that can be done by macros, which you cannot do in functions. Now the whole point of using our own macros and functions is of course code reusability. So let's say I want to call this macro once again. I can just type in my macro and I can call it. Now one difference I would like to mention, and then we'll head into the next one, which is collapse graphs, is with a function. Let's say I call this my function. I can actually execute this from another blueprint, but this is not true for level blueprints. It's a little more tricky to do it from level blueprints. You guys will understand why once we actually head into classes and stuff. But I'll just show you guys a simple example. So I'll just create a blueprint here of type actor, and we'll talk in depth about this later. And let's say I create a function. As you can see, the same features in the blueprint are available here, and let's just call it one test, for example. Compile that. Now if I were to get an object reference to new blueprint. So I'll just do that by dragging it into the level. So I'll drag this and I'll create a reference. And if you can notice, I can actually call test from here. However, if I create a macro, so let's just call this one test m for test macro, you would see even once I save and compile everything, I cannot call test m. I see test, but I don't see test m. So that's one more difference between a macro and a function. You cannot call a macro from, other blueprints, but you can call functions from other blueprints. Of course, if you set the access specifier to be private in that, then you can't call functions either, but you can by default. Now, what if you didn't want to reuse them? What if you just had this code, but this looks a bit messy, so you wanted them to be shown as one node? Let's say this whole thing did something. One, you could just press C on your keyboard and comment it. However, there's another feature in Unreal called collapsed graphs. Now you can right click and click on collapsed nodes, and it's going to create a collapsed graph. Now you can have inputs and outputs here as well, but in my experience I have never really bothered using them. And let's just call this one my collapsed graph. And if I go ahead and type in my collapsed graph by right clicking, so let's say I type in my collapsed graph, you see I cannot call it because this is not a function. This is just all of this code just stuffed into this collapsed graph. So I lost my event graph here. You can head back in, or you can click on this over here. So that's basically a collapsed graph. That's about it. And when we actually use them, you will get an idea. You can actually have further execution. So let's say I have this. So it's going to come out of here as well. So stuff like that. So I'll go ahead and delete that. It's not of much relevance. Now that we have studied about functions, macros, and collapse graphs, let's actually look at implementing the various programming constructs inside Blueprint. So we'll use the level Blueprint again, and after this we will get to actually working with Blueprint classes. Now, the first thing that you would want to do is do an if check, and we already did that several times. So if you right click and type in branch, or you could just type in if, or you could hold down B on your keyboard and left click. That's another shortcut which I like to use. You would bring up a branch node. So a branch node takes in a boolean, and depending on its value, it's either going to go true or false. This is an execution pin again. So depending on the value of this variable, you can go ahead and execute some logic. So instead of health, let's say I have be alive as a variable. So if the player is alive, for example, so put that in. So if the player is alive, then we are going to go ahead and run this logic. Otherwise, we are going to run this. Now, there's another thing which you can do with booleans, which I probably mentioned for enums, but you can actually do a select as well. So if I go ahead and select, you can go ahead and do this. So again, you can actually get this return value to change depending on the value of this variable. So this comes in pretty handy. Now this is the most basic type and there's nothing much to explain really. So you could go ahead and print something and maybe do something else. And if he's not alive, maybe you can go ahead and you can quit the game or anything like that. So that's basically it. Now, the next construct that you'll use is switch. Now switch is something which we already talked about, but we are going to go a bit more in depth now. Now I'll change this variable to an integer again, or rather I'll just undo everything so that we have our integer back. Okay, I've saved it in between, so we can't. So I'll just change the variable type. And for this, we are going to rename this to, let's say, health again. Now I have health. So, oops, let's just compile that again. Control drag it. Now if I drag off of this and type in switch, you would see that I get the switch on int node. Now basically what this means is if I just click on add pin, and you can also set the start index. So let's say you want it to be -1 to start with. You could do that as well, -2 for example. So what you're basically saying is if the value of health is 1, head into this execution pin. Otherwise, default is basically like an else. So if none of these correspond, so let's say we have 1, 2 and 3. If the health is neither 1 nor 2 nor 3, it's going to head into default. So for example, if I just go ahead and print, now since our health is 0 and we are starting at 1, we should get hello printed in theory. So we get hello. If I go ahead and drag off of 1, you're not going to get anything. Now the same thing, if I just change the value to 1, I change the health variable value to 1, now you should get hello. So this is how switch works. Generally you would be using this with enumeration. So for example, we have my enum over there. So let's just delete everything in the graph. Now my enum. Now if I grab this into the graph and if I then type in switch, you see you get the options. So if health, okay, we can rename that to something a little more descriptive. So let's just type in some enum. So if some enum is apple, this is going to be executed. If some enum is banana, this is going to be executed. If some enum is mango, this is going to be executed. So this is basically how switch works. So that's about it actually. Now, this was for your selection and to evaluate condition. Now coming to the iterative constructs, let's say you wanted to print numbers from 1 to 10. You can use a loop. Now if you guys are familiar with C++, these will seem much easier to deal with. There are basically two types of loop and there is a version of while loop called do while loop. So the types are while and for. And there is one more type which you use a lot, which is for each, and we will get to that once we start talking about arrays. Now if I right click and type in while, you see you get while loop. So what this basically means is as long as this boolean is true, so I can change this to boolean once again. As long as this is true, this loop body is going to be executed. So for example, let's say, let's actually make this a number again. Let's change this. Let's say I wanted to print numbers from 0 to 10. So I'd set the sum enum, or we'll call this one num. We can set num to be equal to 0 by default. And now we can do an if check. As long as number is less than or equal to 0, or rather 10, we can go ahead and print our number. So we can go ahead and type in print string, and we can just Control D, print it out. Now obviously this is an infinite loop. You have to change the value of num itself. So what I can do is I can set num to be equal to num plus 1. So this is one way to do it. Also, if you were to notice, if you just drag off of this and type in plus plus, you can actually do increment as well. So this is basically like your num plus plus in C++. That's how you would interpret that. Now if I go ahead and press play, you should see we get numbers from 0 to 10 as expected. So that's basically how you use a while loop. And once this loop is done, again you can go ahead and print something. So let's say printed numbers. Now you see it prints from 0 to 10 and it just goes to completed. This is how you'd execute your logic. One thing to note though, avoid using loops in your program, especially in Blueprint, unless the array length is, less than about a few hundred, it's fine. But let's say you're dealing with larger data sets, please refrain from using loops in Blueprint. try to use as much as you can in C++, because Blueprint, if I haven't mentioned yet, is slower compared to C++. When you call print string, for example, this is actually a function call in C++. So the actual function of print string is written in C++. It actually takes a little bit of processing to actually switch between Blueprint and C++. Blueprint is kind of like your JVM, where it actually runs on a virtual machine. So Blueprint code is going to be comparatively slower than C++. But in this case, this code is pretty simple, so you don't really need to do that. We will get to where to use Blueprint and C++ much later. There's nothing much to worry about for simple games. Now the other type is going to be a for loop. So if I just type in for loop, you see you get for loop. This is how you basically execute your for loop. However, this is a little more, or actually much more easier than what you have to do in C++. In C++, you give an initialization expression, an update expression, and a conditional expression. I mixed up the order, but anyways, you get the point. And you got to actually give the body of the loop like that. But here in Blueprint, you just type in a first and a last index, which makes it very simple for you to execute a for loop. And if you were to just drag this in, let's say I just type in 0 and 10, and I just go ahead and print this. We don't even need a variable at this point. We can just grab this and we can go ahead and run this, and it's going to print 0 to 10. So this is how you use a for loop. Now there is another variation known as the for each loop, which is used similar to range based for loop in C++ to iterate arrays and stuff like that. We will talk about that. Now again, the completed works the same way. Once this loop is completed executing, you can go ahead and print something or execute whatever logic you have. So this is your for loop. And there is another variant of for loop called the for loop with break. So if I just type in for loop with break, you see you get this. Now let's say I wanted to stop at a certain point. Let's say, I mean in this case it's kind of useless to do it. But let's say I wanted to stop in between. Let's say I have some logic. We can just grab in some random logic. Let's say this number divided by 15, we have to make this float, remember, because integer division works in a different way. So let's say this number divided by 15, if it is greater than 3.5, we want to break. Let's say we have that logic. So we are going to print as long as this number divided by 15 is greater than 3.5. So do that. If this is true, we are going to break. Whoops. And if we go ahead and print this, we can just go ahead and print the number instead. And once this is completed, we can print something else. Now obviously to tidy this up, you can use a reroute node and you can do this. So this is one way to keep your blueprint graph tidy. So we can type in completed. So that's done. And we have a compiler error, it says. So okay, we'll take that in as a float. So convert this pin to a float, convert this pin to a float, and then let's just do that. And let's compile this again, save, and go ahead and press play. Now we would see it's 52. So if we actually bring up our calculator, so we get 51 by 15 is going to be 3.4, and 52 divided by 15 is going to be 3.466. So that should be the last number. So now if I do 53 divided by 15, you see you get 3.53, which is greater than 3.5, so it did not print that. Okay, now that we've talked about iterating, now it's a good time to head into our for each loop. Now for this, we'll need to learn about another data structure. Now this is a variable, right? Over here, where you select the variable type, to the right of it, you get an option to change it to an array, set, or a map. Now, an array is basically a collection of homogeneous elements. So basically, in this case, num is now no longer a single number. Instead, it is a collection of numbers. And why I say homogeneous is because I can only have integers in this list. I can't have 0 and I can't have a string in the next index. So basically, each item is going to be referenced by an index. So the first item which you put in is going to be 0, stuff like that. You can put in any number. And if I have to iterate through this, I will use a for each loop. Now, if I go ahead and print this out, you would be able to see that I print in all the elements in that array. So I printed in 2 and 32, which is exactly what we have. So that's basically how it works. Now, one more thing, you can have it of any type. In case you guys were confused, I'll create a new one. For example, let's just call it one str array, and let's make it of type string, and let's compile that. And I can go ahead and add a few elements. I can just type in any set of characters, and I could iterate through this as well. So I can just drag this in, compile that, and go ahead and run this program. Now you see, you can print that as well. So this basically stores multiple of the data types elements. And one more thing, since this is an array, this is more of a theory thing, but the elements here, so this string, so let's just actually name it 1, 2, and 3 for our reference. So 1, 2, and 3, these are actually stored in continuous memory locations. So iterating through them is actually a relatively cheap option. Now, unfortunately, Unreal Engine does not provide us with a linked list structures in Blueprint. We have to implement that ourselves if we needed to, but most of the times you'll be using arrays and maps. You'll not be using sets or linked lists most of the time. However, it is handy to use linked lists in some very rare occasions, but we will not be going over that anyways. So let's just delete all of this. We are done with this. So that's basically your array and your for each loop. Now you can have an array of structures as well. It's totally fine. So I guess we called ours mystruct, if I'm not wrong. We could have an array of those. That's about it. Basically, you could store any type of element. Now I can go ahead and click on the plus icon, and I can add the name and points, and it works just as you would expect. So I can go ahead and delete this. We don't need that anymore. Now, along with your regular if, switch, and your loops, Unreal in Blueprints provides us with a couple of handy nodes which you might need. One of them is called flip-flop. So what does it mean? So flip-flop is basically this is how a flip-flop works. If this execution pin goes in once, A is going to be executed. Otherwise, if you come here again, B is going to be executed. So let me actually show you what I mean. So if I just drag this in, and if I print, and let's just say A is executed, and now if I just go ahead and give in a delay of, let's say, a second, and if I copy this over and let's just type in B is executed, give a delay of a second, and again head back over there. So I'll just use a reroute to make things a little more clear for you guys. Now make sure you guys do comprehend this logic correctly. If I go ahead and press play, you would see it says A is executed, B is executed, and it's going to be alternating like that. So that's the use of a flip-flop. You could use this for key presses. So let's say you wanted something to happen when you press the key once, but you wanted something else to happen when you press the key again. So for example, let's say you have a scoping in thing in your game. So let's say you're scoping into your weapon. Let's say the first time when you flip-flop to A, you want the guy to scope in, and when you flip-flop to B, you want your weapon to scope out. So that's basically one place where you can use flip-flop. So it's pretty simple. Now, one more thing which the engine provides is do once. Now do once, and there's also a gate node which you might need, but I've honestly never gotten an actual use case for this, so there's nothing much to really worry about this. But it can come in handy depending on your game, especially if you're going for puzzle type games maybe. I'm not really sure. So do once, basically as the name suggests, it just allows you to execute this one time. So let's say I print this string and I go back to this. This is no longer an infinite loop. It's just going to execute it once. Look, it just executed hello, and that's about it. Now, let's say I want to call this function just once again. So what I can do is I can drag this into reset. So if anything goes into this reset, the function which goes after completed will be allowed to execute once again. So that's basically how do once works. I don't think there's any explanation required for it. So if I do it on tick, so basically every frame it's going to allow you to do it once again. And if I just go ahead and re-execute this, I know this is an infinite loop, but we do have a little bit of a duration for us in the tick. So that's how it will work. Okay, so it did stop the execution over there. That's a different thing. But yeah, basically reset is going to let you do that once again. So I can actually get a more practical example. So let's say we have a delay of 0.2 seconds and we do this. I can actually use a sequence. So sequence, remember the node which we used before. So after 0.2 seconds, I can go ahead and reset that. And after let's say 0.5 seconds, I can try executing that once again. So if I go ahead and press play, you see it works as expected. Whatever we spoke until now were just the basics in order to get you started with Unreal Engine. But in order to actually practically create a game, we need to first go into some background so that we can learn how to use classes and objects. Now, if you guys aren't aware, Unreal Engine or any game engine in general is going to be working on the principle of object-oriented programming. A bit of a background here. So there are two main programming methods that we'll talk about now. The first one is procedural programming. So this is the approach used in languages such as C, where basically your approach is mainly using functions. So procedures, that's what basically procedural programming stands for. So you have a main function and you have several other functions. Now this is the most simplest form of what it could be. However, you could have a function over here as well. So let's say you have function 4 for example, and maybe function 4 can call function 2 or vice versa. Doesn't really matter. But basically your whole program is divided into multiple functions and there is some global data on which it operates on. So you have some data over here and maybe function 3 accesses some data here. Stuff like that could happen in procedural programming. However, the approach which is used in Unreal in object-oriented programming languages such as C++ is going to be object-oriented programming, of course, as the name suggests. And here we use a principle known as classes, and an instance of this class is known as an object. So let me be a little more specific here. So all the data and functions, so for example, or in this case, this was a method, this was the main function, so we have one method here, another one, and we also have some data over here. So all of these is going to be encapsulated into a unit known as a class, and I will get to some examples later. So once we have this encapsulated, we can go ahead and create instances of these called objects. So basically your class acts as a template for these objects. Now the first question that pops up in your mind would be, why do we use object-oriented programming over procedural? Well, it's pretty simple to explain that. So if we look at the wrong approach, that is procedural programming, you would know that you would have a character, let's say for example. So let's actually talk about a character which you'll have in a game and how you would approach it with both programming methods. So in procedural programming, you would have a character, of course, you're not defining any unit known as character, but let's say we have a character in a program and you're going to have several functions. So you have move, turn, jump. Of course, you'll have other functions. I just took the most bare bones example. And obviously, you'll have the character's transform. And if you guys forgot about what transform is basically location, rotation, and the scale combined. Then you're also going to have a velocity for the character, health, and other variables pertaining to your gameplay. However, there is one problem which you might notice. We do not have a unit which we can recognize as a character. So we have several functions. Let's say we call the move function, for example. Now, when we call the move function, we actually have no idea which character we are moving. So character itself is not actually an entity. So we don't have an actual entity known as a character. Our program just has functions. Same with the transform. We cannot instantiate another character. So this entire code isn't reusable. So that's the problem. Now, what if we head back into the object-oriented type? So if we head back, and if you can see here, we have a class and we have instantiated several objects. Now, if you were to actually model a character with this, you would have your character class. Obviously, with the above mentioned functions and data, I didn't want to rewrite that. So you'd have a character class. And now that we actually have a unit which we can identify as a character, we can go ahead and instantiate a character, and let's say we call it character 1. So we are going to instantiate it. And let's say we have another player, let's say an enemy. So we can go ahead and reuse that once again and instantiate character 2. So now we don't have to rewrite all the functions, and whenever we are actually writing code, we have an idea of which exact character we are referring to. So character 2 is actually a real-time entity, and this is known as an object. So character 1 is an object, character 2 and character 3, all these three are objects. Now if you were to remember, in our blueprint nodes, we had a target pin. So if I bring in, for example, set actor location, so I'll just use the same node, so set actor location. Now you would notice there is a character pin. Now if you were to just hover over it, it says actor object reference. Now in our programming approach, what this basically means is we have set actor location defined in our class. So let's say, for example, we have something like this. So we have our actor class. Now anything that can be placed in the level is called an actor. So let's actually create that. So actor. So inside actor, you actually have a set actor location method. So set actor location, I'll not write the whole thing. And let's say you instantiate actor 1. So let's call it A1, for example. When you instantiate actor 1, your program needs to know on which actor set actor location has to be called. So we have actor 1. So that is our target. So when we call set actor location, in our case, in our blueprint, we called set actor location. Now it needs to know on which actor it has to perform it. So when you call this, through the target pin, in blueprint, that's how you do it. In the target pin, you specify that, and the program knows that it has to set A1's location. So that's how it basically works. Alright, so it's time we apply whatever we learned just now. So head into your content folder and create a new folder, and we'll just call this one blueprints. And inside here we'll create all our blueprint classes and we will compare all of them. So basically the most bare bones one which you can create is an object. Now please do not confuse this with an actual object. We are creating a class and the class name is going to be object. We are basically deriving a class from this object class. This is how you basically start in blueprint. However, as you proceed further, you will understand. Note that this is not an actor, so I cannot drag this into a level. Now, as I'd mentioned before, Unreal Engine already has a 2D vector structure, but just to showcase what we can do with such classes, let me just actually create a 2D vector. So let's just call this one 2D vector, for example. Now please note, you cannot name a type with a number beginning in C++. However, you can do that in Blueprint. So let me just call this one vector2, for example. So if I open this up, you would see you have a standard Blueprint editor, you have an event graph, but you don't have your viewport and stuff like that, which you would see in an actor. Now one more thing you would notice is you don't have an event begin play. So you get an option to add a custom event, which is basically like defining a function, but it does not return anything, and you can call it just like a function. And we will be using a lot of custom events, so you would get an idea of what I mean. Now, in vector2, we are going to have two variables. The first two are going to be floats. So obviously we'll think about what we can have later on. So it's going to be an x and a y. So these are the variables which are encapsulated inside this vector2 class. Note that this is not an object, this is a class. And when we actually create an instance of this, we create a vector2. So that's how it basically works. Now, we don't want this x and y variable to be directly accessible. Now, the reason I want it this way is for data security. Now, I don't want to be directly able to write any random value to x and y. Let's say this was exposed and you could actually change this directly in memory. What would happen is, now for example, let's say I have a vector2 object. So let me just create that. So you use the construct object function. So construct object from class. So I think I misspelled that. So construct object from class. Yep, there we have it. So I'll just delete this. And if you go ahead, we will get access to our vector2. So vector2, for example. Now we have a vector2 object over here. So this is actually a vector2 object. We could go ahead and promote that to a variable. So it's going to create a variable of that type. And let's just call this one r vector. Now we don't want any other external entity to actually be able to directly set x. So this would be prone to lots of exploits basically. So that's the reason what you generally do in object oriented is you make this private. You see the option over here called private. Now basically you will not be able to access x and y from here. So now if I type in get x, you see I can't get it. If I type in set x, I cannot set x. So that's one way of providing security to the data. Now, what if you just wanted to access the value? That's pretty simple. You would just go ahead and create a function. So you type in get x value, for example. So get x and get y. And we are going to make this pure functions because we are just returning the immediate value. And we could add a compact node title and call this one x. And we'll call this one y. Now in the return node, we could just go ahead and return the value. So return node, and we can go ahead and grab our y here and return that. And over here as well, we can go ahead and return x. So grab in the return node and return x. So now if you wanted to access x or y, you can go ahead and type in get x. So you will get access to the x value. However, you will not be able to edit x directly. So again, for that, we can go ahead and create setters. So setters are basically just functions which are going to set the value. So let's say I type in set x and I type in set y. I accidentally typed x again. So set y. Alright, so once that's said, we can go ahead and take in the value. And this is going to be of type float. And we can go ahead and set our y to be equal to that. And we can go ahead and type in the return node. We don't really need it in this case, but anyways, we'll have it. And in our set x function, we could do the exact same thing. We could add in an input pin and call this one value once again. Value. And we can go ahead and add in a return node. Whoops, we didn't need that. Now what if you just wanted to set this entire vector? Now when we set our vector, we are actually just getting a reference to it. We are not actually setting our members. So we can go ahead and write a function for that again. We could add a get vector to, and we could also have a set vector to. So something like this. This was just to show you guys how we would work with classes and objects. So for get vector to, we can go ahead and actually return the value. So we can go ahead and add in the return node, and we can get our x and our y. So things like that. So for a set vector 2, we can go ahead and alt drag this once again. Now obviously please do understand that this is kind of impractical. Unreal already has a struct built in which handles all this for us. I'm just trying to show you an example of how you would actually use it. So this is how you do it. So now if I type in set vector 2, you see I can actually set its value, and the target is our vector, so we are adjusting this value. And we could go ahead and write in a few more functions. So for example, we could write a function to print the vector 2. So print vector 2. So we can go ahead and type in print string, and we need a world context object. However, it is going to take the outer object by default, I believe. But anyways, in these contexts, what you would want to do with something which I haven't seen much is you would just get the outer object. There is a function for this. Basically, the outer object is the object from which this object was created. So in our case, it's our level blueprint, and we can call the print function from there. The reason is it actually needs to know where to actually print the string. So that's the reason actually. So now I can just type in self. Self refers to this object itself, so we can just pass that in. Now we can go ahead and actually print something. So in our case, we can get our x, and one handy function which you'll use a lot is going to be append. So we can go ahead and type in x for the x value, give a space, and then print out our x. Move that over there to keep things clean. And we can go ahead and do the same for the y as well. So we can go ahead and give a space, and we can type in y with a colon, and we can go ahead and print that. So we have our y. We can go ahead and convert that once again, and we can go ahead and print that. If you right click, you can actually remove the extra pin. So that's an option available as well. So now this is how you do it. Now if I go ahead and press play, obviously we are not calling it anywhere. So now that we have our vector, we can go ahead and call print vector 2. So this is going to print our vector. So this is how it works. And obviously we can also test out our set functions. So we can type in set vector 2. And we can just give some random values to this, and if we go ahead and print vector 2, we should get that value. So this is basically how you would work with the most basic type of object. Now this is mostly useful in cases where you only need some data and methods, and you want methods basically, because in Blueprint you cannot have struct methods. So in those cases you would use an object type. So we are not going to be messing with this any further. Now the next type which you will use is going to be an actor. Now this is probably the most commonly used type, and most of the other types of classes which you'll create will also be derived from actor. So let me just create that. Right click, go to blueprint class and create an actor. It's directly available here, or you could search down there. So if I create an actor, we'll call this one my actor, for example. Now, if you were to notice, if I drag this, I cannot do that. because you cannot place a vector 2 in your scene, right? However, I can drag my actor and I can place it in the scene, and if I hit F on my keyboard, I can actually see it. Now this is just a visual representation in the editor so that you can actually see it. However, if you hit G on your keyboard to go to game view, it actually won't be seen. Now if you were to open your actor, you'd see the editor is a little more complicated than your basic object. You have 3 tabs: the viewport, the construction script, and the event graph where you will be working with most of the time. We will separately talk about construction scripts and we'll also get to the viewport, but of our relevance is the event graph right now, and we will talk a little bit more about actors. You would also notice that we have our begin, play and tick, which we missed in our basic object type class. Now if we wanted to have multiple of these actors, so let's actually do something practical. Let's say we had a pickup actor in our game. So we have pickup actor, and it's generally a convention. You do something like this, BP underscore pickup, because more often than not, or here if you see the parent class, it says actor, right? So more often than not, you will actually create another class of your own in C++. So any code that needs to run fast or something, you would put that in C++, and then you would derive BP pickup from the C++ pickup actor. So that's why it's a convention. I usually name it like this. So I can go ahead and grab this. So I have BP pickup. Whoops, deleted the wrong thing. So I can delete my actor here. BP pickup 2 will be created. So these two are pickups, and both of these contain all the variables and functions which this creates. So we can go ahead and edit our blueprint just like how we would usually. Alright, so it's time to dive a little bit more deeper into some of these events, and let's actually start writing some practical code. So event begin play is called not when the game begins actually, that's the wrong way to interpret it. However, event begin play is called when this actor is instantiated. So for example, we have our BP pickup here, and since this is placed in our level, this will get created as soon as our level starts. So it is technically called when the game starts. However, if I just go ahead and print this, and let's just call this begin play, you would see 2 begin plays because we have 2 instances of our BP pickup. However, it need not be called when the game begins. It is called when the pickup actor is actually created. So when BP pickup is created, that is when it is called. So let's delete a vector 2 stuff. We don't really need it. Now in order to actually create an actor, remember that every actor is going to have a location, rotation and scale. So that's the reason you cannot just create an object, because you do need a certain number of default parameters in order to actually be able to place something in the scene. So without a location, the engine has no idea of where to place it. That's the reason actor exists. Now if you head back into your level blueprint, let's actually give a delay of a few seconds just to show you guys. So let's say we give a delay of 2 seconds, and in order to create an actor, you call a function known as spawn actor. So spawn actor from class, and over here under spawn transform, we could just set that to 0 for now. It's since we don't have any visual representation, it doesn't matter honestly. So once that's done, we can go ahead and select our BP pickup, and we can go ahead and compile it. Now if I press play, you see begin play is called, but 2 seconds later another begin play is called. If you guys couldn't catch that, I'll give a longer delay. Begin play, and another begin play was called. And if you would notice in the outliner, you would actually notice another instance being created here. So if you were to notice, there is another BP pickup that is created. So that's basically how it works. And tick is called every frame. However, it need not be once again. So if I just go ahead, or I can just go and reuse it actually. So instead of this, I'm going to type in tick, and now this should be called every frame. Let's only have one pickup actor, and let's go ahead and not spawn this. So if you want to disconnect pins like that, by the way, you can go ahead and press Alt over here, and it's going to disconnect the pin. So we don't need that. Now if you were to notice, it's going to constantly print tick. So this should be about 200 to 300 times a second on my computer. So if I just type in stat FPS, whoops, missed that, stat FPS, it's locked at 120, so it's 120 times a second. So if you want to increase it, actually you can remove the cap by typing in t dot max fps space max fps. Give something like 999 or 1000. Alright, so I don't know why I did that. Now head back into your blueprints, under your pickup, and under your class defaults, you can actually disable your tick. So you can go ahead and disable, and as you can see, nothing's being printed. Now there's another thing. You can actually change this parameter at runtime as well. People don't know this, but any and all details which are there in this panel over here. So let's say, for example, I go to my class defaults. I will definitely be able to change most of these at runtime. So for example, we have start with tick enabled. So we should be able to enable or disable tick at runtime. So let's actually just type in tick enabled. And as you can see, there is actually a function which lets us do it. So if I go ahead and actually enable tick first of all, and if I go ahead and disable it after 1 second, you would notice that tick is being printed, and a second later it stops printing tick. So that's basically how it works. And not only that, any and all parameters, and you can actually change the tick interval as well. Let's say it's printing too often, you could just set it to 0.5. So it will be roughly 0.5 seconds. Now as you can see, it is not printing as frequently. So that's basically one aspect in blueprints that is handy to know, because any and all settings that will be there will be usually exposed as functions to be adjusted at runtime. Otherwise, again, you have your class defaults where you can actually set them. I think whatever we did till now is clear now, so we can go ahead and delete this code. We won't be using it as of now. So now let's go ahead and actually write some code for the pickup itself. So let's say we had an object and we had to pick it up. First things first, there is no visual representation for the object. So let's say we actually just go ahead and, whoops, we go ahead and press play. You would see that you can't actually see anything. Now, if I zoom into this, so as you can see, you can't actually see this pickup. So first of all, let's actually add in a model and stuff like that. Now, there is one thing. The default scene root is not actually required. If I delete it, I won't be able to. However, I can actually add in a static mesh. Now, a skeletal mesh is a mesh which contains bones and stuff like that. So basically, your characters and anything with animations is going to be a skeletal mesh basically. However, your models like your pickups and stuff usually are going to be static meshes. So that's basically how it works. As you use them, you will understand. So now if I drag this into the default scene root, I'll go ahead and delete the visual representation and the static mesh will be replaced. Now one thing to note, when you do this, the most high component, the component which is the uppermost in the hierarchy over here is called the root component. So for example, this default scene root is the root component now. When I drag this static mesh, this is the root component, and if physics has to be simulated, in our case, let's actually try that. Let's make the pickup fall down and follow the laws of physics. So in that case, we will need it to be the root component. So that's one thing to note. Now, if I go ahead and select a mesh, so for example, I can just select this random sphere that we have. I think it's way too big, so yeah, we got to adjust that. Now I can go ahead and enable simulate physics. So now if I go ahead and press play, you see that it falls like you would expect. So we basically simulated physics. Now we have a visual representation. Now how are we actually going to pick this up? Now actually let's select something a little more smaller because I don't think this is convenient. Okay, this seems like a reasonable size. So if we go ahead and press play, we are simulating physics, so absolutely no problem with that. And one thing to remember, in case you are not simulating physics, make sure you do have collision and stuff like that. If we actually encounter such an issue, I will go ahead and show you guys how to deal with that. So we have physics now. Now we can go ahead and set up some logic now. We want to be able to pick this up when we overlap it, let's say for example. So we can do on actor begin overlap. So what this says is when another actor overlaps this actor, so in our case it's going to be this, when it overlaps this actor, we can go ahead and perform some logic, and Unreal Engine has set this up for us. Now there is one problem though. This is just our cube, which is our model. However, we don't have an actual bound, so our code won't really be able to know when to actually call on actor begin overlap. So even if I disable collision, so the way you do that is you can head over here, and from physics actor you could go ahead and change it, but we do need physics, so we can't do that. Even if we actually bump into this, you won't really notice anything happen. So if I go ahead and bump into this, nothing is really going to happen. Now if I actually go ahead and create a bound, so the way you do that is right click, or rather go to add, and you can type in sphere, I believe, sphere collision, yes. So when you create a sphere collision, we could call this one bounds. You would have created a sphere, and you can't see that because the size is too small. You can go ahead and increase the sphere radius. Now these are our bounds. So as soon as we enter this, our on actor begin overlap will be triggered. So we can go ahead and print it. And if you were to notice the collision preset over here under the details panel, select this and head into your collision preset. You see it says overlap all dynamic. And obviously if you select custom, you can go ahead and edit each channel, and we will talk about this later. So if I go ahead and press play, you see we get hello every time we overlap it. Now hello is going to be printed every time any other actor overlaps this. However, we want to print hello only if a character overlaps it. And it need not be a character as well. Now in Unreal, character is actually a derived class of another class known as pawn, and I will talk a little more in depth about this right now. So basically this is how it's laid out in Unreal. Basically we are looking for a pawn, and I will get to that in just about a minute. So we can type in pawn, and if you were to scroll down you would see cast to pawn. So cast is another programming feature. Now if you were to feed in an object to this, you can check whether it is a pawn object. So now if I go ahead and print this out now, you would go ahead and actually get hello just normally. The reason is, when you are actually controlling your camera over here, you are actually controlling a pawn actor. Anything that can be possessed by a player controller is known as a pawn, and we will talk a little more in depth right now. And just to clear your doubts on whether this logic actually worked, let's say it wasn't a pawn, so which means it's not a player basically. So if I copy this over, and instead of hello, let's just print not player. And now if I go ahead and press play, you'd see you won't get anything. And if I overlap it, it says hello. But if I go ahead and copy this over, and let's say keep it above this, and if I press play, you see you get not player printed. That is because the box overlapped another box, or rather our BP pickup overlapped another BP pickup. However, those are not characters. So this cast right here failed because the object which came from this actor begin overlap was not a pawn. Hence, we got not player printed. Now, since we are still at the beginner part of the course, I'll just tell you guys the most basic form of inheritance hierarchy which is there in Unreal. However, once we get to the more advanced part, I will tell you guys more in depth. But as far as what you guys need to know, So at the base level, the most simplest type of class from which you can instantiate objects is known as object in Blueprint. So object is the simplest type, and from that, the most basic one which you can create is going to be an actor. Now an actor is basically an object which has a transform and can be placed in the level, as you would have figured by now. Now under this you have various other classes. However, for the most basic level, we are going to be considering only two. So there are many more, and we will talk about many others where once we actually come to the advanced part, but these are the two which you do require to get up and running. So the first one under this is going to be your controller. So a controller, as the name suggests, is a class which has functionality for you built in to take player input and stuff like that. And under controller, you also have a special type known as a player controller, and there are others such as AI controller. So you have a player controller. So player, and I'm just going to put this. So player controller. Now a player controller is basically a controller which belongs to an actual player. You also have other things such as AI controllers, which is assigned to CPU players basically. So if you have enemies in game for an offline game or something, you would assign an AI controller. Now another class that you'll need is pawn, and that's what we talked about. So this is called pawn. Now a pawn is basically a class which is an actor obviously and can be placed in the level. And note that you cannot place a controller in a level, although it is derived from actor, it is actually an exception. Controllers, player states, game states, there are a few other classes which are exceptions and you can't place them in the level. However, pawns can be placed in the level, and a pawn is always possessed by a player controller. So a player controller is going to be possessing a pawn. So when you call the possess function and you give the target as a pawn, you are going to be possessing the pawn. And one special type of pawn which has a lot of functionality built in for us already is called a character. Most of the times you will be working with characters and not pawns. However, you can use pawns. So by character I mean a character such as a living being basically. So generally if you have like a human, or if you have like an animal or something like that, you would generally use characters. However, if you have something like a vehicle, you would usually stay away from characters because it has some properties which are not realistic for those. However, it is completely possible to use a character class for something like a vehicle as well. So you can possess a character as well. There is no harm in that. Pawn or any derived class of pawn can be possessed by a player controller. Since we have the basics in order to get us started, we can go ahead and actually create our own character class, or I should rather say pawn class, which is also a character class in our case. So we can create that as well as a player controller, and I'll show you guys how to set those and how we can go about interacting with this pickup using those. So right click, go ahead and create blueprint class, and as you would see, you have character and player controller right here because they are really common. So type in character and let's just type in BP underscore character. Again, you can name it appropriately or as per your wish. Now if I go ahead and open it up, you see this looks a little more different and it already has something set up for us. And some of these are quite handy, especially the character movement component which is there. And if I haven't mentioned yet, whatever we did here under the components tab, these are called components basically. Basically every actor is made up of several components, and you can actually create your own components as well and make them behave as you wish. But as of now, just know that these are just constituents of this actor, and these are the constituents of BP pickup, and these are the constituents of BP character basically. Now we haven't set a mesh and we don't really have one, so let's just take, okay, we have a character, tutorial TPP, and one thing to note, this arrow actually represents the forward direction of the character, so you can go ahead and move it down and you can go ahead and rotate it 90 degrees. So let me have snapping enabled. So rotate it by -90, and you can go ahead and bring him all the way down until I feel it's correct. Now we don't have any animations, but I'm not really sure if we do have an animation blueprint for him. So let's just check tutorial animation blueprint, I guess. Tutorial TTP animation blueprint. So yeah, we do have an animation blueprint for him. Now, if you want to change the default character that you will be using, the way you'll do that is by first of all heading into Window, World Settings, make sure that is enabled, and then over here on the right hand side, head into World Settings, and under Game Mode Override, you can go ahead and set your own game mode. Now, if I were to just select game mode, I still cannot edit it. So I will get to game mode classes later on because they're not that important, but for now you can just go ahead and create a new game mode, and it could be of type game mode base or it could be of type game mode. It doesn't really matter, but I would suggest sticking with game mode base. And let's just call this one BP underscore game mode. I just did something there. So yeah, BP underscore game mode. That's what we'll call it. And now under this we will get our option to select the game mode. Now since this is our custom made game mode, we get the option to select the default pawn class. And over here we can select our BP character. And if I save everything and if I go ahead and press play, you'd see that we have indeed possessed our character. And you were to notice that the camera is a bit off. So what you can do is you can actually create a camera. If I go ahead and type in camera under the component section, you can create a camera and you can align it as per your requirement. So this should be about correct. So I feel rotating this a bit, maybe a bit back, maybe a bit to the side would be nice. So there you have it. So this is our character. However, we are not actually able to move. The reason is we haven't actually written the code for it to take our input. Now, setting up input in Unreal is really easy, and I will show you guys the brute force method as well as the proper way to do it. So the brute force method is, for example, we want W to be able to make us move forward. So you can press W, and if you just give a space and type in keyboard, you would be able to get W, and we can make the character move forward. So in order to make your character move, basically there's a function for us built in already under the character movement, and not character movement, I believe it's there in our pawn class, I believe, or a character class. So if you right click and type in add movement input, so it's written in our pawn class, we can go ahead and make him move. And if you were to notice, we have to provide a direction and a scale value. Scale value is useful if you're on a joystick or something where you can partially press down. So let's say you're halfway pushing the joystick knob. So in that case, it would be 0.5. So the scale value can be given through an axis value. Now, if you were to notice, there is another problem here. When I actually plug this in, it's not really going to work as you would expect. So for our direction, we need the forward direction of the character. So a very simple way to do that is typing in get forward vector. So get actor forward vector. So get actor forward vector. So that's the way you would actually get the world direction. That's how you do it. And if you were to notice, it's not going to work as expected at all. The reason is this has to be called every frame in order to actually work. So the way you do it is type in, or rather we can do it on event tick, for example. So if we go ahead and do it on event tick, I'm just doing this to show you guys how to do it. If I do this, now we would see that our character is moving forward. Now the most obvious question is, how am I actually going to set this up? So there is something known as an axis mapping which runs every frame. Basically what add movement input does is it moves you a very slight amount, and by calling this multiple times in a single second, you are going to be adding